So for this short series of videos, I just want to go through the main material that's going to be heavily tested on the final exam, which is mainly material that we've covered since exam 3. So starting here with complex designs, the key point for the first review item is that complex designs are those which involve two or more independent variables. Now remember, the independent variables can be either independent groups or repeated measures. You can have either one. And the nature of the variables, meaning are they independent or are they repeated measures, will impact what type of statistical analyses we apply to the data. For example, we would use factorial ANOVA if the variables were all independent groups. We would use repeated measures if they were all repeated measures designs, repeated measure variables, or if we have a mix of both, we would use a mixed measures ANOVA. So by analyzing what type of measure we're dealing with, or which types of measures we're dealing with, we can determine what type of statistical analysis should be applied, and that's going to be important for the exam. We should also know how a structure, a factorial structure of a complex design will be laid out. For example, in Chapter 8, PowerPoint, slide number 7, there was an example given where the independent variables were the race of face presented and the race of the participant. To spell that out in factorial structure, it would be 2 race of face colon Caucasian or Japanese times 2 race of participant colon Caucasian or Japanese. Now, if we wanted to analyze how many groups this would set up, we need to just do every mix. Now the answer is going to be 4 because it's 2 by 2, but we could also think of it more granularly. So you can say we have the Caucasian with Caucasian, Caucasian with Japanese, that's 2 groups, Japanese with Caucasian, that's 3 groups, or Japanese with Japanese, and that would be 4 groups, or 2 by 2. So that's an easy way to tell how many independent groups we would have. Now we're going to go into main effect, and subsequent points will come in further videos, but for main effect, we're really just asking, did an independent variable have a serious impact on a dependent variable or not? The way that we do that is by comparing the average of the quantified data between 2 levels of the independent variable of interest. What does that mean? Let's look at image 1 here. In image 1, if you take the average value for men, it's going to be somewhere up here. It's going to be 85, right? If we just look at it, all the values are 85. The average of a data set in where all the data points are 85 is going to be 85. For women, the average is going to be 65. And it's that way across control groups. Now, because the average for men is higher than the average for women, there is a main effect of gender, since the average value for women, as we see here, is higher than the average value for men. But if we look at the average value for treatment or control, the average of 85 and 65 is the same as the average of 85 and 65 on both sides. What that means is that there's no real difference. So there's no plausible main effect of treatment condition upon the dependent variable, which is the score on the y-axis here. Let's take a look at image 2 by contrast. In image 2, if we look at the average for the treatment versus control, the average for treatment is clearly higher than the average for control. But if we average across men and women, the averages are going to be pretty much the same. The lines are pretty much the same. Because of these 2 observations, we can say that there is a clear main effect of treatment condition because the average values are different for each treatment condition. But there is no main effect of gender because the average values for both levels of the gender-independent variable are the same. So image 2 shows the opposite relationship as to the one demonstrated in image 1. There's a main effect of gender in image 1, but not of treatment. But in image 2, there's a main effect of treatment and not gender. Hopefully, thus far, we're able to understand what a complex design is, the different types, how complex designs are represented in factorial structure, and what main effects are. Also, we looked at 2 different examples of main effects and we discussed how we can use the average, or the visual average, to determine which independent variables have a main effect and which don't.